Hello everybody and welcome back to a new episode of the TypeScript Tea Time. I'm your host Mirko and hope you're having an awesome day today. Today we are going to continue on the startup idea that I had, which in summary is for people who have sensitive skin and who happen to often have problems with skincare products, which they need because they have sensitive skins, but on the other hand are very susceptible to like reddening or getting pimples or dry skin and so on, caused by those products. And finding new products for them can be quite a challenge. So the idea is to basically give them an app where they can just take two photos. One photo of the product itself and one photo of the ingredients list. And then they just say upload, and after hopefully just a couple of seconds, I think about they use the users actually being in the shopping center, in the mall, having the product in their hand, taking the photo and not wanting to wait more than 30 seconds, or I would even say more than 10 seconds. And then they basically get a report. This is probably going to happen if you use this, judging from other people that have used this, judging from your reports that we have from you, and your skin type, and just regular reactions that come with the products, with these ingredients. Focus being on the allergic reaction for the time being. And yeah. Last time we already checked out AWS Extract, which helped us to, given a photo, let's see, something like, something like this here. Okay, that's vice versa. Yeah, maybe like this. This is my salad, potato salad. I took a lot of pictures of pretty much everything I have, which has ingredients written on top of it. Of course, it's in German because I'm in Germany. Maybe we find the soap somewhere in here. Somewhere I should have. Yeah, here, for example, my ingredients list for my toothpaste, aqua, sorbitol, hydrated silica, and whatnot. And you basically take a picture like this and Textract, AWS Textract, which we checked out last time, then marks, essentially it extracts all the text that it can find in this image, gives you bounding boxes around it, and then you even can, specifically, so it's using machine learning, it is trained on forms. So when you have like government forms, maybe a passport and all of that fun stuff, then it's very, very capable to parse that and immediately give you the information either in just key value pairs. So something like you have a name in the form and then your name or the name of the whoever filled in this form. You can extract the form dot, let's say, name, or you can even ask a question, and it uses natural language processing, I suppose, to answer the question. Then we tried that as well. It was it worked kind of, but it, for example, in an example like this one, we had one for my soap, which is probably somewhere in here. Yeah, somewhere within these 52 pictures that I have, it only parsed or marked the ingredients as like the first 2 or 3 rows, unfortunately. Not realizing that the rest of all of this is also part of the ingredients. That being said, there's no way for us to train Textract. So that means we're probably on our own on that front. Meaning we have to train our own model. And one thing that I'm looking into for that now is AWS SageMaker, which we did also last time. And did a quick audio check, that's just there to ensure that everything is working. So yeah, we took a look at AWS SageMaker, which is a hosted machine learning solution from AWS. You just give it a data set. The examples all include CSVs, but it seems you can also use image labeling and all of that fun stuff. And a way to train this, so one thing that you always have to do, or typically you have to do if you do not already have a perfect model or good enough model, you have to train your data, your model, sorry. You feed it with data that you have provided solutions, and then the model gets better and better and better, hopefully, and hopefully also generalizes well, and then you can use it to predict stuff and give it new pictures, like for example this one, and then it just picks out this part here, which is the ingredients list. This is yet another picture of my toothpaste. Yeah, so we are going to today train this model. To do that, we have to have a way to actually mark stuff in the in SageMaker. And a way to do that is AWS SageMaker GroundTruth. So if we go here to SageMaker inside of the console, so I'm logged in with my user in the AWS console. I assume you have that set up. If not, and you want to get started, I don't think we've ever set that up, but you can just follow one of the many tutorials or just the docs on AWS. We did last time set up AWS SageMaker. So if you want to do that, either just follow the getting started. There are a couple of videos out there which probably help, or take a look at the video we did last time on Monday. I think it was Monday. We went, I think, to Canvas in our case. We launched Canvas. We have apparently 2 apps. I'm not sure which one is the right one. Oh, this one. And inside of there, we created one model. So it looks like Canvas is one way to do it. There are a couple more. Canvas, I think, being the simplest one. You just give it a CSV, and then it does stuff. This one apparently is not a CSV, but at the end it does seem to be a CSV after all. And then you can run your models on top of that. We, for example, we did follow an example course or workshop from AWS where we given some data on like a telephone provider and servers, like for a specific customer, how many night minutes or minutes she called at night, how many, what were the calls at night, how many minutes international calls, evening calls, day calls, and all of that fun stuff, how many customer service calls. And then we wanted to predict whether somebody churned, which means left the company, or stayed with the company. Having that kind of knowledge, I don't know why it says area code is the target. That shouldn't be the thing. Churns probably won't be one. Maybe I picked the wrong one, or I deleted the wrong one. That's also possible. This being just a 2 category, either they churn or they don't churn. There are other types in here. So we did that, and the model was fairly comfortable, and we did use it for some predictions, but I don't have a telephone company, so I don't really have any data that I can then act on. Given this information, that I think in that case it was the customer service calls that was the most predictive, whether somebody will, the number of customer service calls, most predictive whether somebody will churn or not, which is kind of not surprising. But sometimes you have something more surprising than this one. But that gives us a way to very specifically look into ways very, very specifically to look into ways how to reduce our churn rate to keep our customers. What I want to do today is take a look. So if I go back here into the SageMaker console. Oh no, why do you open that one? So SageMaker, let's just reopen it once more. At the very beginning. There we go. Cheers. In here on the left side, we see GroundTruth. And GroundTruth is a way to label your data. What does that mean? That means we provide the solutions for what we expect later on the machine learning or the AI to do. But to get the AI to a point where it can do our work, we first have to train it. And for that, we have to have basically questions with solutions. It's basically like if you train for a test, for an exam, it's very, very nice and useful to have the questions, then work on the questions yourself, but also have the solutions so you can check against the solutions. And that's basically the same idea that we have. In this case, we will be, or using GroundTruth, we can be the ones that provide the solutions. So that's where I want to go. Can I click on GroundTruth itself? No, I cannot. Okay. Yeah. So there are like multiple setups. Apparently there are 2 new ones that I have not seen before. I'm new to this too. Be aware of that. I did watch like a 10-minute video on the basic setup, which I extracted this here from. And that's what we're going to get started with, I think. So the first thing that we want to do is essentially create a labeling workforce, which is basically a team. People that, because you typically don't have your developers that actually do this kind of work, they're too expensive. To be honest. Instead, you have other people, and you could use something like Amazon Mechanical Turk, which is a service of just probably low-paid people, probably underpaid people, who then do the work for you. But you have to do some setup for them so they know what to actually do. But you can also do it pretty much yourself or with a team of yourself. I'm going to start there because I don't want to pay for Mechanical Turk just yet. I want to, first of all, test it myself. That's why I'm going to go to Labeling Workforces Private, and then I'm going to create a new team with AWS Cognito. We could use something like OpenID Connect if you want to integrate, for example, your Active Directory. That would be a thing as well. But I'm going to just use the AWS identity provider, which we've used a couple of times here on the stream, AWS Cognito. I'm going to call it T-Time Test, or Test GroundTruth maybe, well, maybe T-Time Test. Invite new workers via mail. I'm going to use TypeScript T-Time at gmail.com. Organization name, this is the TypeScript T-Time, let's call it like that. Contact email, I'm just going to use the same one. Is that okay? That's okay. Email invitation, that I suppose that's going to be fine. Let's just do it. Create. We could add some more stuff. For example, apparently we could set something up so that with AWS SNS, a simple notification service, so that we automatically send emails out when new data is there to be labeled, because you might be running out of data that can be labeled. In my case, I have like 52 pictures prepared that we're going to go through. Maybe not all, but at least some. All right, we have that one done. We have this sign in here, and I should have received an email, I think it's like that. Yeah, there it is. Yep. Show that. Wait, cannot show. Because it's public. So in here, I can use TypeScript, tTime. Maybe I just use the link. So to log into your labeling pro. Let me set this up ever so quickly. Okay, I was just redirected to this page apparently when I clicked on the link. I will show the link in a minute. It has a temporary password in there which I don't want to share with you just now because it's currently active. Yep. Password. And it immediately asks me to generate a new password. That and so it looks like this at this point, and send, and it should log me into SageMaker. There it is. All right, so since I've set up the new password, I can now show you the email that I've got. Looks like this. Hi, you're invited by probably that was the contact name that we provided, I think, from TypeScript tTime. That's the organization name, I think. To work on a labeling project, click on the below link to log in. Temporary password or username, and then you actually have to immediately set your password. All right, we got that one rocking. There we go. And now I'm going to log myself in this browser as well. Oh, is that wrong? Oh, TypeScript tTime@gmail.com. And any second now. Yeah, there we go. Perfect. All right. No, thank you. So this is the page that the people that work for you and that actually do the labeling work, which can be a bit laborious, see. And as time goes by, we will actually hopefully see some jobs inside of here. So basically what we did is this step. Let's go back to this one. So we have set up our team. And if I refresh this one, so we down here we see, cannot see it. Here it says force change password. If we refresh, it probably says everything is good now. Private. Yeah, confirmed. That's now. Very nice. So from here, we're going to be going back to GroundTruth, and now we're going to add labeling jobs. I'm going to create a new labeling job, and I call this tTime. I want to specify a label attribute name different from the labeling job name. Label attribute name is the key where your labels are stored in the augmented manifests. No, that's fine. tTime, let's call it test. Automated data setup, I think that's provide this the location of the data set you want labeled, and let GroundTruth automatically connect to and use the data set. Yeah, that's what I want to do. So what we have to do is provide an S3 bucket for the input data. So that being said, we have to go to S3, which is the file storage solution from AWS. Welcome in for the new people. I'm going to check out today AWS SageMaker, in particular GroundTruth, which is a labeling service, so that you can provide the solutions for the data that your machine learning gets trained on, so that you can actually start up your machine learning stuff. I think last time we used this TextRact T-time TextRact test. Let me create a new folder. Let's call this GroundTruth. GroundTruth. Server-side encryption. No, thank you. Not necessary at this point. And inside of there. Wait. So we have to provide two things. Lead. One being the input data that GroundTruth works with, and one being the output where GroundTruth puts the results, the labeled stuff. I'm going to create a new folder, call this one GroundTruth input, create, and create a new folder GroundTruth output. That's actually not necessary, but I think structurally that's not terrible to have. And now I should be able to browse S3 right there, go to TypeScript T-time, that's the wrong one, T-time TextRact input, choose. So that's for the input data set. S3 location for the output, we could just use the same, or I'm just going to use the one that says output right there. Apparently I have to click on this icon here to choose the directory. Data type, images in our case. So we could also use text or CSV, video files apparently, or video frames. No, that's it. We are going to use images because for the startup that I think of, again, the idea is people take pictures, or the startup idea that I have is people take pictures like, come on, all of these in this terrible format. Like this one, of the skincare products they use, and we want to have the ingredients. It says Inhaltsstoffe here in German. Weird pronunciation. Here, it's on my toothpaste. It just says ingredients. Kind of scared to find out what is in my toothpaste and what I put into my mouth every day. Yeah. So if you've worked with GroundTruth, please, or anything with AWS, very interested to hear about that. So please write in the chat. Say hi, by the way. Always welcome. We have to provide an IAM role so that probably SageMaker can access the S3 buttons. I think we just create a new role. We could use this SageMaker execution role. But let's just choose another one. The bucket is called the bucket was called Time TextRact something. Wait. Work? Yeah, that looks good. Alright. And then we have to click this not so obvious button to actually do all the things. There are some additional things. Let's see. Data object selection. You can use the full data set or create a subset of your data. Interesting. So we could, for example, immediately only pick some images of the 52 pictures that I have right now, which I took like earlier, of everything that I possess. So that we immediately have like data that we can actually apply the trained model on for verification. And not just like, I think you always say something like the terminology is the training data, the training data sets, and the test data sets. Test data sets being those are there to verify, training data set being the ones that you have labeled. You did provide the solutions, so to say. And that your machine learning algorithm, whichever you're using, learns to understand the data with. And then you apply the model that you create with that, the thing that has learned, the brain, kind of. You apply that to the test data to see how well it works. For now, I'm just going to use the full. That should be fine. Encryption key not there. Completed. And in the meantime, I think we can go inside of here. Oh, would you look at that? Apparently, it immediately set something up, even in the input, and not in the output. In here, we should be able to upload stuff. And that's what I'm going to do. Where do I have it? Here. Folder. Excuse me. So I'm just going to pick all of these pictures, throw them inside of there. They're fairly large, like 6 pages apparently. 52 pictures. Yeah, 52, 127 megabytes. Do it. Upload. This may take a moment. 2 minutes apparently. Connection error. There was an issue with your input dataset. GroundTruth could not set up a connection with your dataset in S3. Please check your input data setup and try again. Or use manual data setup. Because it's empty. So for all 3, there is no file with a specified data type in the S3 prefix. That's because we have not uploaded anything. I think that's the issue. So we probably have to wait just these two minutes for the upload to complete. And then we do that again. Click the button again, and that should work. Thinketh. As a man thinketh. Yeah, I'm very interested. I once saw a stream about this on GroundTruth. There are a couple of pre-made models as well. Although I don't quite know where you can actually get them from. Where is it? Here it is. So that would be something interesting. Maybe it's synthetic data or something. It was a stream here on Twitch in the AWS Twitch channel. And they looked at, I don't know, I think they recognize patterns, knitting patterns. So, for example, this basic one, or yeah, here we see a couple of them. Maybe make this slightly larger. Yeah, and it then told you what kind of knitting pattern it is. I think that was the use case they had, which is kind of a multiple choice, right? If I'm not mistaken. Or if there can be combinations that actually even more than multiple choice. So let's see, how far are we? 86%. Let me switch on the lights. I can do a quick stretch in the meantime. So, hands up and stretch. Straight back. And now just into the, so move the shoulder blades back, and just do a front wrist muscles. That's already pretty nice on the back. All right, so we got that one. Let's try to do the thing again. Is that one now? Complete data setup. Come on, you can do it. Yay! It was successful. View more details. Let's do it. Apparently we have an input manifest location, which we can look at. This one, I think. Right? Not sure how it actually looks like. Can we look at it? Open. Okay. It's empty. Yeah, it's empty. Apparently. Okay. But that wasn't too useful. That was probably the old one. Oh yeah, we see here size 0. This one is probably the right one. The manifest file, open that one again. Hey, and there we see, so we have source references S3, and then just the URL essentially inside of S3 inside of this bucket to the JPEG file. I understand that part. All right, let's continue. Now, what kind of task are we talking about? We already said that from a category perspective, we are talking with images. I'm not 100% sure what we need. It might be one of these two. So what do we have here? We had image classification. For example, is this whole image basketball or is it soccer? In this case, it would be basketball. Image classification multi-label, so there's a human, or there are humans inside of here, there are cars inside of here, or vehicles. There are no animals inside of here. We have bounding boxes, finding the right thing inside images, around specific objects in your image. So I think we're going to do this one. Or that one. One of these three might actually be working. We need more information than there are ingredients in this image, I think. So I think we're going to go with bounding boxes for the time being. Semantic segmentation also sounds very precise. So here we have like bird and bird, and there might be like I don't know, cat inside of here, or egg, or nest, or maybe I don't know, leaf, and so on. And you can, I think, label multiple of these. This one sounds fairly complexish in that these are very precisely cut out. This one is very simple, probably very fast. This one, get workers to draw pixel level labels around specific objects and segments in your images. So this might be actually the perfect one in terms of really exactly defining where our ingredients are and where they end. But it might be too much in terms of processing power. We probably don't need that much. I hope we can get by with bounding boxes. What else do we have? Label verification. Get workers to verify existing labels in your dataset. We don't have any labels. I think we're going to start with bounding boxes to check it out. Course needs to be enabled because we are going to access this, the S3 bucket, I think, from this page here, which is the workforce overview web page. Tags, yeah, there's always one tag that I use, created manually. All right, so next one. Not sure why it pushed me down there, but yeah, let's scroll up. And here comes the part where we have to set up the labeling workforce, which we did at the very beginning. I can just now select this t-time test team. I want to have maximum time the work can work on a single task. I don't know, let's say 30 minutes. If you take more than 30 minutes, actually more than 5 minutes, then it's way too much already. Task expiration time, the amount of time that a task remains available to workers before expiring. Please see here for information on default. Let's just stick with 10 days. Enabled automated data labeling. SageMaker will automatically label a portion of your dataset. It will train a model in your AWS account using built-in algorithms and your dataset. When you enable this, training jobs use new computing resources on your behalf. It might actually be what we need-ish. The automated data labeling. I think that's the stuff that I've seen. What I'm not sure. Much a batch transform job and whatnot. What within scores. Yeah. What I'm not sure is what it should actually. It doesn't really know what it actually should label just yet, right? So in our case, it would be the ingredients. So let's stick with not enabling this, and we're just going to check out the basic one, the manual one, essentially. Display existing labels. Yeah, do it. Oh, very nice. Well, label attribute name. I want to display existing labels from the database for this job. Well, the existing labels cannot be found in the input manifest. Because we do not have anything yet. I actually want to have this, but there are none yet. Suppose we start here. Enter a brief description. Mark the ingredients. Including the word for including the word ingredients in the respective language. So labels, ingredients. We actually just have one. Done. Right? Okay. Can I do this? Yeah. Can I preview it? We found some potential errors with your usage of crowd HTML elements. Okay. So what we can do here, if we scroll down, we see this bounding box thingy. And with this, I can just draw. You haven't selected a label. Okay. Let me select label, and then I can just like all of these. Can I move it? It has shortcuts, so I can just. Oh. Apparently, I cannot move it. Let me do that once more. From there to there. All of this. Submit. And that's the answer. Okay. Submit. So it seemed to have worked. And that should be it. Can we now display labels? Not yet. Right. Additional instructions. Unnecessary. Great. Oh no, why did it remove the No! It deleted everything. Where's that? Mark the ingredients, including the word ingredients in the respective language. Now, create. Do it. Ba-bam. Status in progress. Okay, labeling job has been created. Not sure what exactly in progress at this point means. I think it's running, so people can label now. So let's go back here to SageMaker labeling console. I don't know whether that's the right name. Hello, Vio. Good to see you. How are you doing? He's on you. I'm currently checking out AWS SageMaker and in particular AWS GroundTruth, which are, well, the SageMaker being the one that is responsible for anything AI training, modeling, and GroundTruth being essentially label. You provide the solutions that you can then train your machine learning algorithm on. How have you been doing? Hope everything is all right on your end. Still says in progress. We have to log out before we can see anything. Refresh the page to see if there are new jobs. Good. Not yet. So, label dataset. Shouldn't these be labeled dataset up? None, I guess. I think. Excuse me. So I suppose we just have to wait now until it works. Labeled object, that is in progress. We refresh this once more. Oh, there we go. We have it now available inside of our labeling UI. Let's fill in some more tea and then we can start labeling stuff. And hopefully at the end of, like, I don't know, 20, 30 of the labelings, we can actually run some tests on it, hopefully, with the model. Yes, first of all. There's nothing but. Nothing goes. Huh? What do I want to say? The green tea is great. That's what I want to say. All right, let's do this. Start working. Yeah, fun stuff. So I have like 5 minutes time. This is my muesli. And we have the Zutaten right there, the ingredients. So, and we can mark it like so, and then we can say a bit. If there's only one, it also immediately takes it, I suppose. This is my Japanese sauce. So I'm basically now going to show a lot of pictures from my kitchen and from my bathroom. So that we can label all those images, because that's basically the idea. We have to find or we have to train our model, right? And we first have to have data that is already providing the solutions for the machine learning model to work on. There are, most likely, if we look around in the internet, in the wide web, there are most likely already pre-trained models, and there are probably already pre-labeled like solutions. Like these images probably already exist somewhere on the internet. I did not find them yet, and I wanted to check out GroundTruth, whether it can do the stuff that we want. So that's why we're going to do this together. It shouldn't be too hard, right? As long as you can read the stuff. Just do this and you're done. And then you can say submit. And inside of here, we do all of this. Actually, I would like to remove this part, but with bounding boxes, that's of course possible. Have you been streaming recently, Vio? Haven't seen you online. Here we have this fun part. I think the CI something is part of that. Or is it just a C1? Not sure. That one. Next. All of this. According to the instructions, including the word. Oh. Why did it stop right there? Well, I think there are more instructions. Now this is interesting. I think it's this part. Basically, what we get from what I think we will get from our users is not necessarily images in a perfect format, right? When you're just in a supermarket, you just hold it somehow, and then you just take a picture of the product, of the skincare product. So I, as the developer of the machine learning algorithm, cannot rely that everything is perfect. So that's why I included some of this. Here. Good. This one is vice versa. Okay, from there to there. So what I think, if we have this, so we checked out TextTract the other time, right? On Monday. And what happened was that TextTract did recognize most of the words, but it did not recognize that all of these lines are actually part of the ingredients. In our case, we had like one example where it just recognized the first line as the ingredients, one where it had like the first 2 or 3, but in no case it actually recognized that all of the fun stuff here is the ingredients except for this number, serial number probably. So what I hope is that if we label this with a machine learning algorithm beforehand, we can shrink down the image so much that we basically, when we feed the image into TextTract, we immediately only have we basically cut out this bounding box and feed this into TextTract, which means we immediately have like a fairly clean version of the ingredients, and we do not really have to do any post-processing to filter out all the stuff that is not the ingredients. That's the hope that I have. This is my green tea, by the way. It contains green tea. Wow. Green tea contains green tea. Who would have guessed that? This is my cooking oil. Who would have guessed that cooking oil contains oil? Then we have this one. Pose all of this. It still says can contain traces of something. I do hope that skincare products do not have this, but I would need to double check. We already got 2 of these types. Oh wait, we only this part. So how many did we do now? Ingredients. This, by the way, CI is cosmetic ingredients, and oftentimes these are like colorants and all of this fun stuff. Chemistry. Fear. That tweet there. Compared to there, I think. How many do we have? These tasks, stop and resume. What do we have here? NER, 3D, point cloud, video object detection, and blah blah blah. Object tracking tasks. If you are applying labels to words within a larger text or annotating one or more 3D point clouds or video frames, select save before you continue. Images. If you are annotating individual images, text or video clips, you will lose all of your work you have completed on this task if you... Wait, what? Why? Can I not just stop? You will lose all your work you have completed on this task if you select confirm. You can start working on this task again. Oh, only for the one that I'm working on? Or do I actually now have to do every 52 of them? Because that would be terrible. That would be pretty amazing. And awful. Pretty much awful. Let's try it. This paused. So we start working. No, everything is good. That is a very, very misleading and scary scary message. This was tofu. Go. I probably shouldn't have taken everything. Can we actually move the bounding box ever so slightly? Like in the sense of like shifting it, tilting it? Okay, treat the data of this task as confidential. That's why I'm showing it on Twitch, because it's totally confidential. Inside of peppermint tea, you have peppermint. Ooh, who would have guessed? Yeah. Fun stuff. Has any of you worked on something like this? Or seen something like this? Data labeling? There are a couple of solutions out there that do this by default, apparently. Like, no, not, how do I say this? That you can use to label it. Open source in particular. You don't necessarily have to use AWS. You don't have to use AWS SageMaker GroundTruth. That's not necessarily a thing. You can just use open source solutions for that as well. This one, of course, integrates well with SageMaker. So within the AWS network, this one is pretty well integrated, obviously. There might be ways to actually import a machine learning model, but I don't know how to do that. I also don't know how to do this locally. The problem that I have now is when we do this, if I finish all of the tasks, we do not have any data left for testing. So I think I will just stop right there. And maybe we can refresh this and hopefully we see 27 are already labeled. Let's just go to 30. And maybe then we can go back and start doing some machine learning on top of this. So let's go to up to 30. So 3 more. Ingredients of this one are all this. On it. Right, second try. There. Mid. Here we can mid. And one more. And we have all of them. But done. Maybe one more. All right. Submit. Done. Okie dokie. We should now have something, as soon as this updates, we should have something like 31 labeled. And let's just see how this output looks now. Like now. We see annotation tool, we see annotations, we see temp, we see manifest. Annotation are probably inside of there. We have the iterations. Look at this one. So what do we have? Acceptance time, answer content. Answer content. We see the bounding box inside of here, label ingredients with its coordinates, and that's pretty much all there is to it. The rest is metadata. Cool. Very nice. Very nice. All right. Now, what I want to do with this is go to, I think, Canvas. And hopefully click on this, yeah. Hopefully we see the data inside of here. Maybe we don't. Because we have to actually create a new one, I think. Add a user. Configure app. I think we have to create a new domain. Launch SageMaker. User. Computer. The part of the somewhere we've set up the S3 bucket. It's notebooks. But did we? I think we did at some point. Oh, no, getting started. automatic model creation, end-to-end work. Got the tutorials. I just want to do it. How about letting me do it? Is it in your user profile? Was it configure app maybe? Domain, no. So, SageMaker dashboard. Maybe from here. Open SageMaker DOM. Prepare GroundTruth, build, marketplace, train and tune, one-click training, appearance, deploy and manage, one-click deployment. So we have apparently one labeling job running inside of GroundTruth. So what do we do next? What we do next? Relation task. Was there something on here that I've missed? The data was not there, was there? Was it? Images. Bigger the app. Got it. So if you know where we need to go to actually see the result data, please let me know. Would be very, very cool. We have a source. We probably have to click import S3. From there, I think output. Notations, worker response, version 1. Oops, no, I clicked the wrong button. Where do we actually import the data that we have labeled now? That would be very, very useful to know. Import S3. So cannot import this whole directory apparently. AWS GroundTruth image to SageMaker canvas. Or do we use it with Notebook? Currently no resources. Let's try this one. Maybe that's what we need. T-time test. Elastic inference not necessary. We just take a small one for now. Jupyter Lab 1. Very nice. I've written some Python back in the day. I have no idea how to do it actually within these kind of notebooks. But we will see. should be this one. Yeah, the role, root access. Yeah, if you like. These are not production settings, so I don't really care about the root access. In production, I would probably restrict this further. But I just want to check it out, so to make it work quickly and not having for you guys not to have to wait for an hour for me to just figure with the policies. That's never fun work, to be honest. Getting the permissions right is just like, if you've ever worked with IAM and had to figure out the permissions, or possibly even ran into an issue with that, can be hard to debug. I think we did the first steps. We are currently trying to actually go into the training mode, although it's not as obvious that I would like to have to get there. Let's wait for this one to actually finish inside of the notebook. Didn't find any obvious place to import all of these responses. I mean, sure, we have them, but we can't even import them currently, so that's not really useful. That's not really useful. Maybe SageMaker Canvas is not working with this type of data. That might be something. Like a canvas, image semantic segmentation, plus single label, output data. Image classification. It is not 100% what we're doing, but we're kind of... Actually, we're doing object detection, I think. Bounding boxes. So... .io, train with the image format. Do we have our notebook already? It is still pending, huh? It is still pending indeed. Status pending. The monitoring logs. And so on and so on. Right. Let's just wait a second here. Maybe AWS Node SageMaker Jupyter Notebook using notebook instances. Let's watch the video, I think. Oh, it's 26 minutes. Huh. Hello, Peter. So. Why do they go to lifecycle configuration? Do we have to start with a lifecycle configuration? That sounds weird. use SageMaker instances, create, access, example notebooks. The notebook instance contains example notebooks provided by SageMaker. The example notebooks contain code that shows how to apply machine learning solutions by using SageMaker. Okay. We are now in service, so let's open. So we have Jupyter and we have Jupyter Lab. So what the difference is. But let's go there for now. Currently it is empty. Notebook list. Let's create a new one. Oh boy. Now I probably have to do some machine learning stuff myself, which I cannot, because I have no knowledge on that one. And I was hoping that I can actually get around having to use them and writing this stuff myself. I mean, that's why I'm using AWS with it, right? Let's try to look at this preview just to see how it works. So I kind of remember now that I see this. It's basically an MD file, a markdown file, but you can actually run this code. The thing is, I don't want to write the code. Yeah, I don't want to write the code. That's the only way to actually train it? No, there is. There is definitely easier ways, like for example SageMaker Canvas. What I don't know is how to do image. What do we actually want to do now? We want to predict bounding boxes with SageMaker Canvas. So bounding boxes with SageMaker Canvas. GroundTruth. Autopilot. Automated ML. Closer data selects the algorithm relevant to your problem type. Prepares the data. Facilitate model training and tuning. That sounds reasonable. That's pretty much what I want to do, right? Again, if there are people out there who have done this, very much invited to backseat, probably to lead me. This is not great. It supports tabular data formatted as CSV or Pocket files, in which each column contains a feature with a specific data type, and each row contains an observation. That's not quite what we have. How do I integrate? How do I integrate the stuff from that we get out of GroundTruth? That's a question that I have. I mean, I can see the output, but how do I use it? That's not as obvious as it should be. Okay. So it's good that there is a couple of examples. Quite a bunch of, in fact. If we find the right thing, GroundTruth labeling jobs. That sounds good. So 3D point, cloud input data processing, not what we're doing. ECS blog post, not what we're doing. Semantic, nope. GroundTruth video quality metrics, nope. Worker address, bring your own model for SageMaker labeling workflows with active learning. Interesting name. Data analysis of GroundTruth image classification. No, we're getting closer. Do we have bounding boxes somewhere? No. Point cloud. Just GroundTruth workflows. Preview that one. So, automate multimodality parallel data labeling workflows with SageMaker GroundTruth and step functions. Okay, sounds good. Data labeling often requires a single data object to include multiple types of annotations or multi-type, such as bounding boxes, lines, and segmentation masks, all in a single image. Is this an example of how to combine them? I just wanted bounding boxes. Additionally, to create high-quality machine learning models using labeled data, you need a way to monitor the quality of the labels. You can do this by creating a workflow in which labeled data is audited and adjusted as needed. This notebook introduces a solution to address both of these labeling challenges using an automotive dataset from the car industry, and you can extend the solution for use with any type of data. We walk through an example situation where you generate multiple types of annotations for an automotive scene. Specifically, we run a total of 4 labeling jobs per input video clip. No, why did it become video clips? I want just images. Object detection. Labeling adjustment. Maybe we take that one. Streaming, chain streaming, annotation dense data point. Image classification is something else. It's a complete image, I think. Cat wants cheeseburger. Let's try this one. Oh wow. From unenabled data to a deployed machine learning model. A SageMaker GroundTruth demonstration for object detection. This is what I was hoping for. I was hoping that it's much less steps. But then again, looking at this list, so introduction, run a GroundTruth labeling job, about 4 hours. I think we did that. We prepared the data, we specified the category, we created instruction template, we created the team, we defined a pre-built lambda functions to use in the labeling job. I don't think we did that. What does this one do? Before we submit the request, we need to define the ARNs for 4 key components of the labeling job. Work team, the annotation consolidation lambda function. But what is the annotation consolidation lambda function? The pre-labeling task lambda function. Okay. So at the very least, this looks very, very promising. Jupyter, how to object labeling with SageMaker. and it does show my notebook, but it's part of the examples. Your notebook dot your region and then all of the fun stuff. In our case, let's call this general link to the notebook. So apparently there are 4 steps. We do have the work team. I have no idea what the annotation consolidation lambda function is supposed to do, and B, and what the pre-labeling task lambda function does. These functions are defined by strings. Maybe we read the introduction first. So, oh wait, what? Okay, be aware when you run this, you may accidentally cause yourself to have like $200 of costs, or at the very least 26, which is quite something. What is it? How does the GroundMaker work? As part of the AWS free tier, you can get started with SageMaker GroundTruth for free for the first 2 months after the first use of SageMaker. Your first 500 objects labeled per month are free for the 2 months. And as of then, I do all of this myself. Price per reviewed object, 8 cents. That's not too little. Even if I do it myself, well, I guess I get the bill at some point, right? So, let's read the introduction once more. It takes you through an end-to-end workflow to demonstrate the functionality of GroundTruth. We start with an unlabeled image dataset. Acquire bounding boxes for objects in the images using GroundTruth, analyze the result, train an object detector, host the resulting model, and finally use it to make predictions. That's pretty much what I want to do. Before you begin, we highly recommend you start a GroundTruth labeling job through the AWS console first to familiarize yourself with the workflow. We did that. So, cost and runtime for this demo. If you're doing all of the 1000 images with auto labeling, in Excel, label 1000 images. The It cost about $200. The current GroundTruth pricing. In order to reduce the cost, we will use this is quite a bit. Labeling uses computer vision to learn from human responses. Okay. So they start, in this case, with 100 images. Still cost $26. Wait a bit, if this is the default pricing. Oh. I mean, I'm not 100% sure what they actually price for just yet. So, going to be interesting. To run this notebook, you can simply execute each cell in order. To understand what's happening, you'll need an S3 bucket you can write to, which we have. Please provide its name in the following cell. Bucket must be in the same region as the SageMaker notebook instance. You can also exchange the exp name, whatever exp means, to any valid S3. It's all the files related to this experiment. Okay. Never use complete words. Always abbreviate. That always helps the people that read it. All the files related to this experiment will be stored in the prefix of your bucket. Okay, the S3 bucket that you use for this demo must have a course policy attached. We did that last time. Yes, the day before yesterday, we enabled course for pretty much everything. To learn more about this requirement and how to attach, see there. Familiarity with Python and NumPy. Basic familiarity with AWS S3. And basic understanding of SageMaker. Basic familiarity with the CLI. Ideally, you should have set up credentials. Okay, I have that one. I don't want to pay $26 though. Let's just see what they do here. So, with the row string, blah blah blah. So they have a lot of imports. They have a variable, the bucket name. They have the experiment name, which is the prefix, or the folder inside of the bucket. Whether we want the full. Whether we want to run the full demo or not, and make sure the bucket is in the same region, getting the execution role. Boto3 is the Python AWS CLI, which has a very interesting name, to be honest. We get the S3 client. We start a session in this region, and then set some header. Oh no, we get the bucket region and assert that the bucket region is equal to the region that we have set in. So in other words, the bucket and the notebook have to be in the same region. So this section should take about 4 hours to complete. Oh wow. We will first run a labeling job. This involves several steps: collecting the images we want annotated, creating introductions. Let me just close the window. Getting quite windy out there. Alright, apparently it's raining like hell. Let's put in some music here. prepare the data. This is apparently a subset of the Google Open Images dataset. Oh, very nice. Very nice. So let me copy this one. If you want to check that one out, good to know there's something like that out there. Also this one. And what we probably want is something, for example, cosmetics. There's no such category, unfortunately. Beauty? Nope. Random category. What do we have? Green? Or toothpaste? No. Clothing. Body. Lemon. No mobiles. Walk. Nice. All right. So there's this set of data which we can apparently use. Now let's go back to this one. Starting and labeling job specification. In addition, we highly recommend that you run a free mock job using a private workforce before you submit any job into the public workforce. Is the private workforce for free? Where do we see that? SageMaker, GroundTruth, private workforce pricing. $0.08 per image. So in our case, for our 52 images, we already had like $5, which is quite a bit, to be honest, for 52 freaking images. Just to train our data. Okay. Not the cheapest. At least not for somebody who's just learning. The good thing is if you actually have a new account, then free. We have like GroundTruth inside of here. Yeah. Apparently, the first 500 objects labeled per month for the first 2 months, once you started using SageMaker, are free or 70% reduced. Which is at least something. Okay. So where do we continue? Yeah. So prepare the data. You first download images from there. These labels were carefully verified. You first download images and labels. I'm confused. If we already have labeled data sets, why would we need to label them again? Later we will compare GroundTruth annotations to these labels. Okay. Our data will consist of images of various species of birds. Okay. With this variable being set to false, we only use 100 images of this data set instead of 1000. There are some interesting images. You are free to ask the annotators to annotate any images you wish, as long as the images do not contain adult content. All right. In this case, you must adjust the labeling job, request this job procedures. If you're using adult content, you probably have to do something else. Check the documentation. We will copy these images to our local bucket and create a corresponding input manifest. That's pretty much the same that we did, right? Disclosure regarding the open images dataset v4. It's created by Google. We have not modified. You can obtain the images and annotations there. Annotations are licensed by Google under CC by 4. I'm not 100% sure. This one includes now share. Oops, thank you. Oh. About now. Copy and redistribute the material, adapt, but you have to give attribution and indicate changes. No additional restrictions. Okay, so it's pretty much the same as version. Wait. CC by 4. The licensor cannot revoke these freedom as long as you follow the license terms. Okay, very good. That's what version 4 does. What else do we have now? Okay. So I think here we just download all the images. Okay, I can accept that. And then we write the image file ourselves. Why? I don't know. We could also just create it as we did, right? And then you see a couple of images inside of the bucket. Specify the categories. Why do we use the... I don't want to use the... I mean, it's great that they do all of this programmatically, but I don't want to do it programmatically. Where do we get to the interesting stuff? Create that one, create a private team. We did all of that. Here we go. Define pre-built Lambda functions for use in the labeling job. Before we submit the request, we need to define the ARNs for 4 components. I think we started here, right? We haven't learned anything new. Wait. We need the work team, the annotation consolidation Lambda function, which is something. The pre-labeling task Lambda function, and the machine learning algorithm to perform auto annotation. I don't want to auto annotate. If you find a mapping, it will enable you to run this notebook in any of your ordered regions. I'm not sure. What is annotation consolidation? Apparently it's a term from SageMaker. So an annotation is the result of a single worker's labeling task. Let's take that terminology. Annotation. Annotation consolidation combines the annotation of 2 or more workers into a single label. Okay, we don't need that. Okay, I see. So that's what it does. If we have multiple people annotating or marking the bounding boxes in our images, we can combine all of these to take like an average or the minimum of them for higher precision. Okay. What then? We have also a pre-labeling task. Lambda function. Yeah. Pre-annotation and post-annotation lambda functions. There we go. So this is part of GroundTruth. Okay. Before a labeling task is sent to a worker, your pre-annotation lambda function is invoked, which makes sense now that they write it like that. Pre-annotation lambda. Okay, so we get a call from GroundTruth, and then we can do stuff. What is is there any specific requirement what this should do? Where is it? Right. So here we define ACRARN. So ARNs are Amazon those names, which are the identifiers, I think, of the lambda functions. This way ARNs for resources needed to run an object action job. Yeah, so this is the complete ARN actually. Where does it say AC? Availability? No, it's AZ, not AC. Human ACS. AWS GroundTruth AC. SageMaker AC. Okay. Not sure what this exactly means. All right, then we can submit the request. Okay, and they do that completely from the CLI. So monitor the progress. We can do all of that from the UI, from the console. I mean, we can just go inside of here, this one, see GroundTruth, labeling jobs, and see the progress right there. Post. Now that we've trained the linear algorithm on our data, wait, where did it become a linear algorithm? Oh, here we go. Here we go. Now comes the fun part. Did it Wait, that's the wrong one. Where's my... There it is, okay. Sorry. So once more, monitor the job process. We can do that from the UI. We don't have to write like 50 lines. Hey homeless, how are you doing? I'm doing well. Checking out today AWS GroundTruth to label or to train a machine learning model so that we can do the image recognition thingy. So my idea is, so what we can do, let me show this to you ever so quickly. GroundTruth is another part of AWS SageMaker, the machine learning thingy. Let's start that one. You've seen this one, right? And now I can, as a human reviewer, kind of, we can create the bounding boxes that we want. And what I have in mind is we train a model so that it makes a bounding box. It only marks the ingredients itself for the startup idea, remember? That then we can just cut out the bounding box, and then we can put in the bounding box image. So all of this part only goes into TextRact. That means TextRact pretty much extracts only the correct text, almost. Which means we do not, well, let's say it like this: the post-processing that we need to do after TextRact, after extracting the text, becomes less, I think, way less. And I hope maybe we can get it so far that there is little. There will always probably be some post-processing that we need to do. For example, we saw one example that it said, do not put into the hands of children under 3 years or something. And it just wrote it directly after this. And the image recognition will not notice that, I think. So there is something that will probably go to TextRact, and TextRact will also get this part of the text, which is not part of the ingredients. So my idea is to train this model, which is surprisingly expensive. I pay like 8 cents per image training this with AWS GroundTruth. So like if I train like 100 images, that's already 8 euros. So I probably have to use the free tier for that. Yeah, but that's the basic idea. And then I can run, hopefully, this slightly nicer. And things get easier. So these are images actually of my foodstuffs. This, for example, is like soya milk that I'm currently drinking. See this one, I think. Yeah, and I would now go through like 30 more. Yeah, it's chicken schnitzel. It's like chicken schnitzel, but it's vegan. Because I'm mostly vegetarian since like a year almost now. I'm surprised about that one. I'm not sure. These are cookies, I think. I bought myself some cookies today for nice work. Yeah, we do love schnitzel. Schnitzel is pretty good. Also, the chicken schnitzel is. Oh, we have I just saw a lightning down there. So if it says with a lightning in like a minute, don't be afraid. Everything is good. These are falafel. The falafel that I have bought, but I haven't tried them yet and actually made them. yeah, so that's the basic idea. And you do all of this fun stuff. And you can actually require other people to do that for you, because it's like laborious work, right? So you can outsource that to other people who do it for you. Yeah, Bockwurst and Bratwurst. Nice. But all of this is meat. So I am not a vegetarian, but I reduced my food, my meat consumption to once a week or twice a week sometimes. Whenever I go out, I don't want to restrict myself to not eat flesh, or meat. But when I'm at home, I try to be slightly more careful in choosing more vegetarian foodstuffs for the environment. I think it's like this. Yeah, and I would need to go through these some more. And hopefully at some point this is done. But it's surprisingly expensive. Usually I eat 4 times a week veggie stuff. Yeah, so it's kind of similar. Well, actually very, very similar. How many days has a week? Oh, it has 7. It's 5 work days. My bad. Yeah. 1 day fish. Oh, that's very healthy. Yeah, I think I should do that one myself. Fish is nice. I actually like also the taste of meat, but to be honest, I like it much more now that I have less of it, which is surprising to me. That with such a kind of easy trick, I can fool myself into actually enjoying the food that I eat more and still help the environment. Very good. Good to hear that I'm not alone on that idea of being like a reductionist is I think the word, right? Reductionist meat. Stop calling yourself a vegetarian. Meat reductionism. Yeah. It's much more effective in winning others over than vegetarian. That's true, I think. They are actually right, I think. Mr. Dr. Ridley Cooper. I don't know what kind of doctor though. Did you have a nice day? So, what I try to find out now, I can label all of this fun stuff. That's fairly simple. Basically, what you do is, there's a very good video. AWS GroundTruth tube. Was it this one? It was like a 7 to 10 minute video. I think it's this one. Yeah, that's the video that I followed. Beyond Meat Burgers. It's very, very good. And the shortcuts that I have from it is basically you upload images into an S3 bucket. We did that. You go to SageMaker and then GroundTruth, so that you also know what we were doing. So here in the sidebar you have GroundTruth right there. You create a workforce first. In my case, I created a private one, which means I myself, or I have a team of people who do that, and then you invite them via email. You can also invite yourself, and they can then access to this kind of UI, and then they can start working. But what do they work on? That's not the workforce, that's the labeling jobs that you do. And there you you pretty much provide, well, the name, you provide the location of the input data, you can then provide also the location of the output data, and what kind of task it is. That's probably the most interesting part. Like, for example, bounding boxes for object detection, very, very precise object detection, image classification, like this, there's a human inside of there, or two, there's a vehicle, there's a street inside of there, there are some trees, I suppose, or just an image, what is this image, or label verification. And that's pretty much it on that part. Was there anything else? You click on the complete data setup. This is for creating data that you can run your that you can train your model on. So it's not a pre-built model. There are ways to actually automate this, but this is for creating the stuff that your model gets trained on, and tested, probably also. Yeah, that's what GroundTruth is for. They call it a labeling service. That might be the GroundTruth AWS data labeling service. Yeah. So providing the solutions. There are a couple of these. I haven't looked into Plus yet. Apparently it is even better, probably more expensive. People have to, the people that you provide are experts. They have to meet data security, privacy, and compliance requirements. Okay, so that makes sense. Yeah. Other than that, I did look some more into the startup idea, by the way. Got some more inputs. If you would like to hear about that, let me know. Otherwise, I will continue. So the part where I'm stuck now is getting from having something, having some model, having the labeled data and putting that into a model. How do I actually get a model out of that? How do I train a model out of there? Okay, so about the startup idea. Currently I'm in the section of learning, right? So what I learned, I have my notes here. I had a nice talk with one of my friends. He saw like two approaches to the problem of getting only the ingredients. One being kind of a brute force approach. So he's working in data security. He also worked a bit with machine learning, but not too much. What he called brute force is, I think he comes from like his idea is you have a complete list of passwords, or in our case, chemical ingredients, and then you match the text that you have from TextTract with those words, and with that you find out what are the ingredients inside of there. For that you, however, need the universe of ingredients, and the universe can be kind of large, I think. Just looking at some of these images, particularly the ones that have perfumes and all of that fun stuff. You have like LORES23, you have PEC7M. There are some that are just called CI and then a number. It's like 50 with 6 digits and whatnot. Here, for example, CI47005, which is cosmetic ingredient number 47005, which is CI47005. But as you can see, these are like 100,000. Not terrible. In this case, it's a colorant, apparently. Quinoline. Did we check that out the other day already? It's again soap, that's why, I suppose. So that might be a bit much. But it might be... but it is a solution, and there might be like hybrid solutions in particular. The other one being like a database approach. There's something called EWG Skin Deep, which is a cosmetics database. This is, I think, ecologic workforce. I forgot what the abbreviation is. But they give you a database, and you can just look for example, Head and Shoulders, apple cider vinegar rinse on. Let me take this one, the basic shampoo and conditioner, sandalwood, and then you see inside of here, in particular, already kind of the information that we want to have. High on allergies, low on cancer concerns. So know your environment, protect your health. EWG home. Let me just find out our mission. So their mission is to empower you with breakthrough research to make informed choices and live a healthy life in a healthy environment. Environmental Working Group, that's the name. I think they take, in particular for the Skin Deep, US products and then analyze them, and fairly scientifically. That's the important part here. Usage restrictions apparently high. I don't know what exactly that means. Label information. So here we have a complete list of the ingredients in particular. So that's something. Apparently they have a PETA certification. One interesting thing is, where did I see this? Here, the Healthy Living app. Kourtney Kardashian. I never thought Kardashian and useful app would be in the same consideration. I would even say consideration, not even sentence. Consideration. But apparently she pretty much created I don't know exactly. I didn't look into it just yet, but it might be the app that I am thinking about. So EWG's Healthy Living app. Maybe that is exactly what I look for, what I think about. I haven't looked at it yet. You can apparently scan the barcode, which is very, very similar to what I had in mind. Barcode is also very, very clever. I didn't come up with that. So maybe they already do that. I didn't dig deep enough, so I didn't click this link yet. But this might actually be the thing that we link the product to barcode. Yeah. That's a very, very nice idea. I'm not sure whether you have, like, on the Japanese products, you actually have barcodes. I suppose you do. So the place where I think about using this and building this for is Japan. Because I have personal connections to Japan, I have personal connections to skincare salespeople in Japan, and it has nicer regulations than Germany in particular, or Europe in that sense, when it comes to healthcare data. Because looking at allergies is kind of on the side of, is this already healthcare data or is it not healthcare data if we anonymize everything? So that's something. But yeah, maybe this is already the thing that you that we need. Let me share this with you as well. In particular, the database is very, very useful. Where did I have this? Skin Deep here. So that might already be something. Apparently they already have like 100k products in here. Only 2,000 of which are actually inside of there. And if you can't find a product, you can apparently build your own report by pasting the ingredient list, which is also by pasting, do not include descriptive words or non-ingredients such as active ingredients and so on. Yeah. So you can paste the ingredients list essentially here and then get something out of there. There's another project that I found. Where did I see that? Which is very, very new, in fact. Only 2 months ago, they started going public, which is Cosmely. But I'm not sure whether they already started. This YouTube video is like two months old. But you have to actually, so they do provide all of this ingredients list, and in particular from the ingredients, which kind of positives and negative effects you might expect from this, which is also a nice idea. But to do so, they actually, at some point she's copying the stuff, going over to the app, and then pasting the ingredients, which is just terrible, to be honest. It's not user-friendly at all. So that would be something that they want to probably improve over time, and where we could, for example, provide special value by coming up with this idea of scanning. Scanning the barcode, however, is just the best way. Thinking about it, the barcode is probably the best way to you can do this to create a database. So that's one more thing that I found so far. Yeah, barcode is an amazing idea. And probably the looking at the ingredients is just step 2. If you cannot find a product, you take the ingredients, and basically what I would think about is, where did I open this? Yeah. It would be a nice addition to their product, that you can just make a picture of the ingredients list, and then it puts it inside of here automatically. And maybe you just have to do some post-processing in terms of letting the user remove the word active ingredients maybe, or other ingredients and so on it may contain. So letting the user post-process it. That's more, yeah. You're absolutely right. I think you were talking about the barcode. That's the absolute most reliable one. Far with a distance. Yeah. So it doesn't seem too great apparently with 3.1 stars, but I can imagine skincare can be a sometimes emotionally sensitive. Not only the skin is emotional, the skin is sensitive, but also the emotion is. It can be emotionally loaded, and maybe some people don't work. Not only find the national brand product by scanning code, but on another product it's totally different barcode number. Yeah, so that's probably something that this is not designed for. Probably Joanne here is not from the US. So because this is the EWG thing seems to be trained on the, or not trained, the database is for US products, it seems. So there are obviously other countries that would benefit from this as well. I can't even see another language inside of here. So they are completely, they seem to be completely for the US. Which I'm not even in, right? Anything else that I found out? One interesting thing is, so when I was talking to my friend about the machine learning approach, he said, well, you have basically the initial data problem in there is a initial value problem. When you start a database, and in particular this kind of data collection about people having sensitive skin and how they react to specific products, of course the first person who uses the product, our product, will have the algorithms will have no data prior to that. So the results, whether the product will be beneficial for their skin or cause any kind of allergic reaction, will be very just like very insecure, very inconfident. It would just be like a general, well, this could cause something, but we don't have any data either about you, neither about you nor about, well, anybody. So the first person and the first people who use the app will not be very inclined to use it, right? This initial value until there is enough data so that the AI can actually tell you, yeah, this is your skin type. These are other people with your skin type. For them, this worked. And to to bridge that, he pointed me to the subreddit skincare addict or skincare addiction, which I found to be an amazing idea to get initial data using Reddit to populate your database to get reviews essentially. What I also found is this is just general information now. Somewhere, I can't find it anymore. Somewhere. So we could do like a sentiment analysis of each post inside of there, try to figure out the product they are talking about, and then use that as result data. that would be another way. This person here is actually doing the thing of what people use and what other skincare companies are actually doing. For example, this Color.io app, it detects your skin type and skin conditions using just your phone, essentially, if I understand this correctly. Just images of your skin. So that's an interesting project as well. All of these projects are out there. Can't find the one that I was thinking. I think there was one where you have a lot of data sets One being Amazon reviews. Is very, very interesting. And very, here we go, right? Stanford provides this kind of data. Amazon reviews, because why not? What could be better than using Amazon reviews to populate a database? And there are a couple, quite a number of reviews inside of here, and we could use, for example, the beauty.text.gz, which is 46 megabytes of data. Do we have like cosmetics? No. Yeah, probably beauty is the one that we want. 250,000 reviews, which would be very, very useful for our initial data as well. If we can parse that using, I don't know, natural language processing, get the sentiments out of there, try to find out what products they refer to, and then we have 250,000. Let's say if only half of these, or only 1/4 of these are good, maybe probably together with the health one. That's amazing data, right? That we can use. It of course takes quite a bit of processing time and also all of that fun stuff, but there are definitely sources out there that we can use to get a trained model. So here comes some interesting pitfalls that we might run into. These are actually fairly obvious once you think about it. I see you're still with me, very good. Because I'm talking now quite a bit, right? It might be that you're just like, you kind of lost me there, but I see you're still with me. Pitfalls. Even if you know the ingredients, concentration of ingredients actually matters. So if you have 1% alcohol in something, or let's say 0.01% alcohol in something, you probably don't have this tingling on your on your skin. Speaking German all of a sudden. As you would have if you had like 5% alcohol inside of there, right? Or 1%. So concentration definitely matters, and you don't get that from an ingredients list oftentimes. There are some that provide the percentage, but most do not, as far as I have seen. Also, the processing and the type of mixing the ingredients chemically does make a difference, right? The sum is more than the result is more than the sum of its ingredients. So different ingredients might react with each other. I don't know, hydrogen peroxide plus water explodes, for example. so is that right? Is that the right one? Hydrogen peroxide explosion? Is it with I think this one combusts. Yeah, but at the very least, what I want to say is, depending on which ingredients work together and how you mix them and mesh them, there might be very, very different results from the original ingredients. Yeah, the chemical reaction. Yeah, that's a much better word. Let me just write this. Chemical reaction matters. Yeah, so that might also change the result. And in fact, that's one thing that here, this Cosmily Cosmely, looking at their app, they, at least from what I can tell, they copy and paste this text into their app, and then they parse the ingredients for specific effects. Do we see this? So this might actually be faulty data, because if polyethylene glycol reacts, for example, with some other ingredients inside of there, it might have a different reaction or result. Let me see some. Yeah, there we go. Moisturizing. Glycerin, for example, if it reacts with something else, it might not have a moisturizing effect anymore. At least as far as I understand chemistry, glycerin could be something completely different at the time you put it on your skin, right? Maybe not glycerin, but maybe something else like hyaluronic acid. You need to know what you can mix and use to. Yeah, you would need, for a very, very precise, for more precise data and information, you would need to understand what works together and how they react together to result in specific effects. Because, yeah, it's kind of synergy, but sometimes sodium overdose. Sodium is a very, very good name.
Sodium_overdose joined our tea time.
For the current stuff that we do with LSP. Good to see you. Welcome to the TypeScript tea time. Cheers on you. Have a cup of tea. Not saying this is not useful. It is definitely useful. I'm very, very sure. Because this is kind of the way that you do the decision making, probably when you create these cosmetics. I'm working on a startup idea, and for that I'm checking out AWS, so machine learning with AWS, and in particular how to create data sets that you can train your machine learning algorithms on. So Homeless is saying there are also different skin types. Absolutely, some skin types are thin and some are thicker, light and dark, and so on. And they are very, very different in terms of what kind of reactions you can expect from them. So Sodium, welcome to the stream. What I'm working on, or what kind of startup idea I came up with is the following. Suppose you have sensitive skin. That means your skin tends to be particularly dry. Whenever you use some products, your skin gets red, or it tingles and burns on your skin. All of that fun stuff. The problem with sensitive skin in particular being, if you do not use anything, it burns. If you do use the wrong product, it burns. Meaning you have to use something, but finding the right product can be very, very difficult. And think about skincare products; they cost you a lot of money. In particular, if you have sensitive skin, it's fairly normal to also spend like 40, 100 to 100, maybe more per month on skincare products. And now imagine you buy this new product, which you hopefully it fits your skin, and then you try it, maybe here on your arm, just to notice, and you pay $40 for it. You pay $40 for the month version, because oftentimes they're not even smaller smaller packages so that you can just test it. And then for $40, you notice it doesn't work. Now you have like a month's worth, and you paid $40 to essentially get red skin. Great. And maybe it also burns, and maybe you get pimples and whatnot. Not great, right? Now here comes the idea. What if in the shop you just take a picture of the ingredients, and Homeless and I now noticed a much better idea would be to scan the barcode, and then you click on the analyze button or submit button, and it tells you, at least to a degree personalized, this product fits well with your skin type. Many people have used it that also have your skin type, and judging from the allergic reactions that you also have reported to us, this should work. We did not find any kind of ingredients that cause any kinds of skin irritation. I think that's the right word. That saves you a lot of money and a lot of regret. Particularly the regret part is very annoying, because the regret part, you buy something that should help you. I have no idea yet. I'm new to machine learning myself. I try to use AWS because it makes it simpler. So that's the basic startup idea, is to help you find skincare products before you buy them, for your skin type, and save you money, save you a lot of regret, because in particular, if you regret the decision, you are much more hesitant next time to buy something, and just having the stress of being regretful and going through this again and again until you find the right product for you can actually cause your stress level to rise as high that you get skin irritations just by using anything, just by buying something or going out, and that's like a death cycle, right? So if we can help that would be great. That's the basic idea. I haven't found an app that does it 100%, but there might be something out there. It's just an idea. It came to me. What I've been looking into so far is TextTract, AWS TextTract, which is a solution to automatically extract text from images. So what we did like 2 days ago. Have you worked with AWS in any form? Let me go to TextTract here. Very, very simple to use, in fact. Try it. Yes. I can just go here, maybe open the containing folder. No? Okay, that's fine. So AWS is the Amazon, on the one hand, backend, but Amazon Web Services is like a infrastructure provider and service provider and whatnot. You've worked with TensorFlow. Oh, very nice, very nice. Then you know more than me. So let's pick maybe, let me find an image that it should work with. Maybe this one. This is my toothpaste. And I can just put this inside of here. Usually I would have like a file storage where I upload my images. And you can also upload images, for example, from an app. And then you can automatically trigger Amazon TextTract to extract the text out of there. So let me click here on queries. And I can actually ask it, what are the ingredients, question mark, at the query, apply the configuration, and it has a pre-built and pre-trained model, and it gives me all the ingredients, as you can see. In fact, it gives me, in this case, an okay-ish answer, let's say it like that. It's not 100%, but in particular, it also parsed all of this other text here. Amine fluoride, probably we have somewhere here, or aqua, tallow, all of this fun stuff. Segment by word. Oh, these are line. Yeah, okay. So, and we even see where in the picture we have the specific text. So if you ever have the problem that you have to go back from the text to the image, you can do that as well. The problem being, as you can see, if I ask this question, what are the ingredients, it recognizes some of it, but it doesn't recognize it's all of it, unfortunately. And that's a problem that I'm currently working on. How to improve the workflow so that we get all of the ingredients and not just part of it. That's a basic idea. And what I do to do that, or what I started to do that, is I want a machine learning model that essentially gives me a bounding box around this part here, about the ingredients part. Does that make sense? And then I can just feed this bounding box with all the ingredients into TextTract, and then whatever TextTract analyzes and the complete words that it outputs is pretty much the ingredient list automatically. Now, the benefit being, TextTract is not trained on this kind of data. It is trained on forms, particularly if you ever have to have something like loans, health insurance cards, vaccination cards even. These can be, it is pre-trained on this kind of data, and you can even put in questions like, what is the patient's name? And it tells you, well, it's Mary Major. Or you can even have like key value pairs, date of birth, 1658, and so on. So what I think is we train a model, or what I think about, one idea that I have is we train a model to just pick out a bounding box around the ingredients, and we can train a model to do that, I hope, with hopefully somewhat high confidence. So it would be just finding one single bounding box, in fact, inside the image. And then, and the good thing is it typically starts with the word ingredients. That's nice. And it is close together in particular also. And then we take this one bounding box, feed it into, as an image, into TextTract. TextTract extracts all the text, and we can just almost without any further thinking, almost, not quite, take the text that we have there, and we have our ingredients list. And then we can do more analysis from there. That's the idea that I have. Do some more analysis and then report back to the user. Does that make sense? Or somewhat? From a workflow perspective. If you have any questions, feel free to chime in. Or any comments also. So what I am able to do now is using AWS GroundTruth, so SageMaker AWS SageMaker is the machine learning service that Amazon provides. And inside of there, it has a sub service, which is called GroundTruth, which you can use to prepare your data. So basically, you get this kind of UI. Can I already start this? Okay. You get this kind of UI, and you can pay people to do this, and they can mark your data. So something like this, for example. These are the ingredients in this case. This is currently my potato salad that I have in my fridge. But we can use that as well. This is hummus. Hummus is great. I love hummus. Hummus tastes amazing. I think these are the ingredients. Not that simple to mark this one. Maybe can I even rotate it? Undo, redo, zoom in, contrast, exposure. Yeah. So that's the way that I can label my stuff, and I was able to set this one up fairly easily. Problem is, how do I use the stuff that I prepared? All of this data that I now have, the labels and the images, how do I use that to actually train my machine learning model? And I have not found the solution just yet. That was where I kind of got stuck, and where I started doing this Jupyter notebook, meaning basically an interactive way to an interactive tutorial, essentially. That is essentially for object detection, specifically for this one. This is provided directly from AWS itself. They do warn you, however, if you run so this is not too cheap. If you run the full demo, this should cost you about $200, which for a learning purpose is not that little. There are, if you create a new AWS account, however, and you use the free tier, it will cost you only half of it. It will still cost you half of it. Remember. Yeah. So that's where I got stuck. I'm trying to figure out how to get the data from, how to use the labeled data to train my machine learning model to do object recognition. To answer your question, that's the kind of machine learning algorithm I want to use. Something with object recognition, and I don't know whether it's going to be deep learning, whether it's going to be, I don't know, whatever. There's neural networks. Is that part of deep learning? I don't know. I have no idea. I hope I can just give that to AWS, and then everything works. Right? That's my hope. But I still have no idea how to actually use the model. So, train an object detector. Let's look at this one. So if anybody here, I see we have a couple of viewers now. Anybody of you has worked with AWS, and in particular GroundTruth and SageMaker, please let me know. I would very much appreciate the hint of how do I use the stuff that I get from GroundTruth to create the to train my model. So analyze GroundTruth labeling job results. So do I actually have to completely do everything, or can I just use the in between results? I can plot it. I don't need to do any of this. Plot the resulting bounding boxes to a PDF. Oh, that's nice to be able to do. Sorry, touching the microphone. But I don't think we need to do this now. What kind of technologies are you working with in particular? I'm very, very curious to learn more. So, is this just plotting the bounding boxes? We don't need any of this. Compare GroundTruth results to standard labels. So in this tutorial, they use they use images that already have labels from apparently a set of images provided by Google. This Google Open Image dataset. That's a thing, and they already have labels, and they now compare. In this step, they compare the results. So how good is the stuff that GroundTruth provides compared to the stuff that gets shipped with Google, because they want to showcase GroundTruth probably. And now I want to go here. Why can I not jump there? Why? Rain and... there we go. So, this sounds very, very promising, right? This is pretty much what we want, I think. At this stage, we have fully labeled our dataset and we can train a machine learning model to perform object detection. Very good. We'll do so using the augmented manifest output of our labeling job. No additional file translation or manipulation required. When did we set up the augmented manifest? Or do we have that already in our S3 output bucket? Manifests, immediate output. How does this one look like? Let's open it. Ugh. Wait. Should be format. Not format this, unfortunately not. We can put this into an array, unfortunately. So what do we have here? GroundTruth object detection, human annotated yes, creation date, job name, and we see the annotation, the bounding box inside of here. So this is the result essentially, and we want to use this probably to create the result. Annotated. Although I haven't done 52 of them yet. There are a couple of them that are not yet labeled, it seems. Yeah, there are a couple of them inside of there that are not yet labeled. Very good. I was confused there for a second. All right. So how do we now put this inside of more stuff? Inside of here. Oh no, my eyes are getting tired. Unfortunately, it's already 21 o'clock. So, for more complete description of the augmented manifest, see there. Alright, so object detection is a complex task, and training neural networks to high accuracy requires large datasets. That's not great, because it's expensive training these datasets, and also creating these datasets is expensive, and probably also training. And careful hyperparameter tuning. That is what I was fearing. The following cells illustrate how to train a neural network using a GroundTruth output augmented manifest and how to interpret the results. However, you shouldn't expect a network trained on 100 or 1000 image to do a phenomenal job on an unseen image. Why not? Why not? I would like it to have phenomenal results on unseen images. After 52 images, in fact. Because that's the amount of images I have. So, first we'll split our augmented manifest into a training set and a validation set using a 80-20 split, and save the results to files that the model will use during training. Oh, and they do it completely manually, huh? So they open the output manifest. We do not have this yet, definitely. Then they shuffle, just randomize the output. They randomize the lines, in fact. That's the output. Get the dataset lengths. So let's say we have like 52 in our case. Train test split index. They take the first 52, the first 40 images to train and put this into the training data, and then they put the rest into the remaining 12 or 10 images into the validation set. This is the very nice syntax that actually Python provides. I like that a lot. I should do some more Python, I think. Then with open train manifest, so they write a file called train manifest where they dump all these lines and a file with called validation. Okay. And now they instantiate SageMaker using these validation and train manifest files. Okay. So what we could do, I think we can do this manually, right? Basically, what they do is, let me see, whenever I have JPEG end, remove the line, and that should now give us all the things that are labeled. Apparently I already have labeled 44 images. Very good. Hey, Max, welcome back in. Good to see you. I'm doing well, mighty well indeed. My eyes are getting slightly tired, unfortunately. Because, I don't know, streaming when it's dark, I did not find the right way to relax my eyes during streaming, unfortunately. So that's a bit of a bummer, but I am fairly happy with what we have done using AWS GroundTruth. In fact, apparently I'm over time here, to label and create essentially bounding boxes around the ingredients of a couple of foodstuffs and all of this fun stuff that I did. This task is no longer available. Damn it. But this one is. So we have a couple of more. So this is what I'm currently showcasing is AWS GroundTruth, which is a way to generate the results for your machine learning, to train your machine learning algorithms on and to verify them. That's the basic idea. And it was fairly easy to set up, this one here. How long did I study English? I don't know. I think we started in school so when I was like 8, 10, 9 years, I suppose. But the way that I really learned English, sorry, there we go, is playing Final Fantasy VIII. I played Final Fantasy VIII in English, and since it's like a 100-hour game, and I read every single text inside of there, that was the way for me to get good in English. School was okay-ish, but getting good in or well in English took some more effort than. Yeah, there are a couple of web pages to parse ingredients. Birdie seems to be another. Very nice. Thank you for looking that one up, Sodium. Thanks, I appreciate it. I still have an accent. In particular, when I haven't streamed or worked with English-speaking people for a long time, my German accent comes back. This looks cool. This is already a nice list of ingredients. Thank you for sharing that. Let me definitely save that one. So one idea also was to create like a universe of ingredients, but the universe might be, or universe meaning like a word list, and ideally all words. Marshmallow root extract. Interesting. But this list might be very long. In particular, there are a couple of ingredients. Oh, wait. Let me do this. There are a couple of ingredients that are just like CI47005. And they still have an effect on your skin, probably, or at least on some people's skin. But it's hard to list these kind of things. There are apparently special chem, the material selection platform, ingredient selector. Hey, thanks. TS and only that's a big step. That's a big step. That's a big step. So, thumbs up on you. Also, we need some more tea inside of the stream. So, everybody, thanks for being here. I appreciate it. I appreciate it a lot. So we have like Special Cam seems to be a page that is designed for these kind of requests, and maybe they have an API even where we can request that. I also showcased earlier. Where was it? There's also this one from the European market. There's a cosmetics ingredient database. I'm not sure whether this is actually the database or there's an actual link, or whether this is just the specification for how the database should be built. I haven't looked into it just yet, but here are the regulations and all of that fun stuff. So there are a couple of things out there that can help you if you're into this. There's also an app. The most comprehensive one seems to be, as this one's more, this :blank. No, that's not it. This one. EWG.org. EWG, the Environmental Working Group. I think that's what the name was for. It stopped working. EWG Skin Deep is a list of, in particular, US products, and they provide you with data on how well this is for your skin and whatnot. Hazard score, Head and Shoulders here is a nice example. For example, it has low contamination with cancerous ingredients. It has, however, some quite high, whatever high means, contamination with allergies and immunotoxicity, and so on and so on. We even see a complete list of ingredients inside of here. So that might also be a way, if we are able to talk to this one. And they even have up here a healthy living app. Let me share this with you ever so quickly. So that might be something, the Skin Deep thing. They even have an app by Kourtney Kardashian. I just find this funny that the Kardashians can be more than just trash. They are apparently even involved with healthy living apps, where you can, I think you can take a picture of the screenshot. Oh, they don't even have this here. Ah, there we go. You can, I cannot click on it to make it large, unfortunately. So you can take a picture of the barcode, and then it directly probably shows you the results page, which is very, very useful. Insort ingredients checker. Yeah, very nice. Very nice. Let me show this one as well. Yeah, there are a couple of solutions. What the benefit that I have in mind is easy usage. Easy usage and a new market. In particular, so the target group here in particular is sensitive skin, and I think about the Japanese market, because I will actually, if I'm lucky, I will go back to Japan in pretty much 1 month, October 4th. Not sure how the stream will go then, but I hope I can continue at least once a week, because I'm going to live with some other people then. In any event, there, for example, this where did it go? The AWS website that I showed a minute ago seems to be designed for America, for the US market, or maybe also Canada probably still works, but Japan has quite a different set of requirements, and it will hopefully be more personalized towards you, analyzing the reports that you also have provided, and seeing what kind of allergies you might have. So, for example, by cross-checking the list of reports that you have provided, and looking, oh, I see this ingredient is this ingredient is in a lot of products that you have marked as it caused some some form of allergic reaction, and it is known to be causing allergic reaction. Maybe that's exactly the thing that is causing you trouble. So we might actually be able to detect allergies for people. And thinking about it going further, this might be a thing that is very relevant for medicine as well, right? There might be actually something out there, like a medicine, allergy detector or something like that, that uses kind of the allergy detector app. Apparently there are a couple of those allergy apps. How to shop and eat out safely. Yeah, that might be something that is very similar. The marketing model that I think about, however, is specifically designed for skincare products for people with sensitive skin, because I think there is a pain point, and at least I haven't found a product that it perfectly matches their use case, and in particular is easy to use. The UX is very, very important, right? All right. Did I save this one? Thank you so much for sharing this one as well, Sodium. Image analyzer. Oh. You can also upload an ingredient list photo from your phone. Let's do that. Let me do this. Oh, interesting. Not sure why it took the complete programming TypeScript tea time episode for 90, I think 91 by now. Here we go. Oh, would you look at that? Very nice. They allow you to do this manually. So where's the ingredients? There it is. Ah, this is German, so it might cause trouble. But let's see. Analyze. Maybe they are doing the thing that we think about. That would be great. Hey, something worked. It's potassium and potassium sorbate. Is that all? Well, it's not perfect, but it did do something. And now we can look at what does it do. It is apparently a preservative, so that the stuff is longer fresh in a sense. Very interesting. Cool. Did I check this? No, I haven't added this to the list yet. Thank you so much for sharing. There it is. Yeah, I think there is definitely opportunity. So what I would continue with is this now, but I think it's time for me to say goodbye for today, unfortunately. I think I will continue tomorrow. I will continue labeling this stuff, maybe take some more pictures, and then we can, and maybe I have to set up Python as well to do this, and maybe set up also a new account on AWS, because then it's free. And I don't have to pay like $200 to do this. All right. So thank you so much for joining. Also, thank you so much for the contributions, everybody. I very, very, very much appreciate it. This was a lot of fun. I'm going to continue right here, I think, tomorrow. Wait. Tomorrow evening, I think. So like similar to today. Time-wise, yeah, I have a brunch tomorrow. Brunch is great. Yeah, there are a couple of tools. I have to do some more research. Thank you so much for sharing a couple of more. Did you use any of those before, Sodium? Thank you so much. So tomorrow, probably similar time. Evening hours in Central European summertime. This was a TypeScript tea time. We checked out AWS GroundTruth, and we did indeed label a couple of things. We got stuck kind of on the topic of actually training our machine learning model with the stuff that we labeled. That's what we're going to do tomorrow. Let's go and rate somebody. Coding Garden is online. Very nice. So he's probably doing some form of JavaScript or TypeScript. He's building a CRUD API with React, TypeScript, and React Query. Very nice. So let's go there. Say hi from him, from the stream. If you have the yeah, thanks so much for joining. Hope to see you next time in TypeScript Tea Time. I'm your host, Mirko. See you next time, everybody. Bye bye. See you tomorrow.